Afternoon. We're going to go over matrices today. I'm first just going to do a little introduction, and then we're going to use the first application of it, which is solving linear equations. I'm not going to go through everything in the PowerPoint/PDF that you have, so make sure you've got that up as well and you look through it as we're going through it. I'm going to first start with, as I said, an introduction to matrices. This is a mathematical science. It's used there's actually a couple of college level courses you take in matrices called linear algebra. First, let me just describe what a matrix is by drawing one up and giving some of the notation. So I'm just going to randomly put up some numbers. 1, 2, 4, 3, negative 2, 0. This is a matrix. It's just a series of numbers inside square brackets, and it's important to use square brackets. If you put straight brackets, that actually means something else, which we'll get to later. The matrix is defined as a size by its rows and columns. The rows go this way. The columns go up, down, like a column would in a house, for example, or a building. This is generally referred to as M, the number of rows, and N, the number of columns. So if you refer to this matrix, you would say it's in this case, 2 rows by 3 column matrix, or in general, M by N matrix. This one's 2 by 3. If you want to refer to individual elements in it, you will use, typically, and this is in the notes, you will use A to define the term, and then say it's 2, 1 would mean row 2, column 1. In this case, that would be row 2. This is row 2, column 1, so this would be 3. Or A, say 1, 3 would be row 1, column 3, which is 4. That's how you define the terms in them, and we'll use that notation later on. If you refer to something outside of it, for example, A4, 2, that just doesn't exist. There's no number there. There's no row 4. So that's the general notation for them. Just a couple of applications for them first. Oh, one more thing actually on that. If the number of rows and columns is identical, so for example, if it's a 4 by 4 matrix or a 3 by 3 matrix, this is called a square matrix. And that'll be, so just generally, if it's M by M, it'll be a square matrix. Okay, some applications for this, other than the math part of it, which we'll do, largely for solving for systems. It is also how most real physics equations are used outside of high school. Things are not one-dimensional. They are 2 or 3-dimensional, modeled as 2 or 3-dimensional, and therefore you use 2 or 3-dimensional matrices to describe physics equations. It's also used in computer science for transformations, movements of stuff around your screen, your phone screen, for example. And it's also used in economics for population models. We're going to just describe the first application of this mainly, which is to do linear equations, to solve linear equations. And this is by far the way they've done. All the stuff we were doing before, substitution and elimination, are not really used that often. Most systems are solved by matrices. So what I'm going to do is I'm actually going to put up an equation first. And I'm going to start with a simple 2 by 2. So here we go. This is the one in your notes, by the way. P minus 3q equals negative 1. And negative 5p plus 16q equals 5. We're going to start by putting that into a matrix form, what's called an augmented matrix. What you do is you take the coefficients in front of the 4 terms there and put them in a matrix on part of it that'll be 2 by 2. So 1p minus 3q and a negative 5p plus 16q. And then you put a little dotted line there. That's really just to keep it separated from the part on the right, and you put the other part over there, negative 1, 5. This matrix is a 2 by 3, and we're going to reduce it. The goal of this is to reduce it to a form that looks like this. 1, 0, 0, 1. And then over here, when we're done, I'm just running out of the room over there, will be the answer. That's what we're aiming for. This says basically p minus 3q equals negative 1, and negative 5p plus 16q equals 5. When you get over here, it'll say p equals p plus 0q. In other words, p equals this, whatever p is. And this will say 0p plus 1q equals whatever q is. So we're going to reduce this. As I said, we'll start with a 2 by 2 or a 2 variable equation, then we'll do a 3 by 3, which is a big mess, as you'll see. Okay, so first step, you're going to do these just like you do elimination, except you're going to do it with without the variable names in there. So if you were going to eliminate p, for example, in the first part, you would multiply the top by 5, so you get 5p, and you add that to negative 5p, and it'll become 0. The p will be eliminated, letter p. You are, by the way, do not eliminate the q first. Always do the first variable first. You'll see when we do 3 by 3 why that's important. Just keeps order to it, and you'll end up with this over here. If you try to do the q first, you'll end up with zeros down here, which will not be great. Okay, so what I typically do is write the numbers above it rather than replace the line. So in other words, 5, multiply the first one by 5, and I get 5, negative 15, negative 5, like that. And then I will rewrite a matrix down, a little bigger, with not changing the first line at all, like that. And in the second line, I'll add this new equation, which I multiply by 5, to my second original equation. So 5 plus negative 5 is 0, negative 5 plus 16 is 1, and negative 5 plus 5 is 0. So I'm almost all the way there, actually, because I have 0, 1, 0. What this means right now is that q must be 0. Now what I'm going to do, by the way, if this said like 2q equals 4 or something, you would divide by 2, but it's just 1, so you don't have to do anything more from here. Now I'm going to eliminate this negative 3, because remember I'm moving for 0 over there. So I'm going to multiply the bottom equation by 3. Again, I'm just going to put it below it, 0, 3, 0. I'm not going to change the equation in the matrix itself. And then I'm going to add that to the top equation. Now it'll give me still 0, 1, 0 on the bottom. And the top one will become 1, 0, and negative 1. So what does that mean the answer is? That means that, for example, now p is negative 1. So my answer is, if I would put it in a coordinate point, negative 1, 0. And now at this point what I do is check my answer, put negative 1, 0 up at the top, and so negative p would be negative 1 minus 3 times 0, which is 0, equals negative 1. That checks. And negative 1, put in the other one, times negative 5p is 5 plus 0 equals 5. Check. So negative 1, 0 is correct. So before I go into 3 by 3, let me just give just a summary of that again. So start with the equation, create an augmented matrix, which means take the coefficients of everything on the left, put them in the 2 by 2 on the left, put what it's equal to on the right, then do elimination. Start by trying to get this bottom, this A21 term, to be 0, then try to get this one to be 1, then get this one to be 0, and finally get that one to be 1. And then you will have your answer at the end. Okay, now we're going to try a little more complex example with a 3 by 3. Or sorry, 3 equations, 3 unknowns. This is going to be a big mess. I'm going to use the one in the notes. I'm actually going to put the equation up here. Rather than put the equation up, I'm just going to start with the matrix, which it says in the notes. I think this is on my PowerPoint. It starts with x minus 2y minus z equals 2. This is, I think, on, I'm not sure exactly what page in the notes. It looks like page 15. So I'll do that. Just to save room, I'm not going to write the equation down. It's x minus 2y minus z equals 2. And the next one is 2x minus y, which is 1, plus z is 4. And the last one is negative x plus y, so it's plus 1, minus 2 equals negative 4. Okay, what we're aiming for, just like on the other one, is 1's kind of down the diagonal and 0's everywhere over here. And with the order I'm going to do that is I'm actually going to get rid of these two first, the 2 and the negative 1. The row 2, column 1, and the row 3, column 1 first, and make them 0. Then I'm going to make this 0. Then I'm going to make this 1. Then I'm going to make this 0, then this 0, then this 0, and then make sure these are 1 in that order. So again, it's kind of going counterclockwise around it to make it look like that 1, 1, 1 across the diagonals, and the answer will then be over here. So let me start with the first step. Again, these are elimination. This is x, this is 2x, this is minus x. easiest one is the bottom one because I can just add that to the top one. To eliminate this one, I should multiply the top by -2 and then add it to the second one. So I'll do that first. So -2 times 1 is -2. Hope we can read that. -2 times -2 is 4. -2 times -1 is 2. And -2 times 2 is -4. Now I'm going to add that to the second equation. I'm not going to change the first one again. 1, -2, -1, 2. I could change the first one, but there's no point. It would just be more complex to make it -2, 4, 2, -4. So I'm just going to leave it. And then I'm going to add that to that over there, and I get 0, 3, 3, 0. Hopefully that's right. I don't have you guys here to help me correct if I make errors. This now says, this second one here says 3y plus 3z is 0, which also means that y is -z, if you were doing this by elimination originally. Now I'm going to get the third equation. I'm going to add the first to the third, so that I don't have to do something new there, because it's just going to directly add the first to the third. I get 0, -1, -3, and -2, which says now -x minus 3y equals -2. Okay, now I am going to eliminate this here and make that 0. I'm not going to even touch the top equation, so I'm just going to leave that. Second equation, therefore, I'm going to have to multiply the bottom one by 3 and then add it to the other one. So let me do that. And stop. This one's not going to change either. I'm going to make that 0, 3, 3, 0. I'm just going to change the bottom one. So 3 times -3 is -3, plus 3 is 0. This stays 0. 0 times 3 is 0. Then I get 3 times -3, which is -9, plus 3. That's a bit of a mess. It's -6. And then over here, 3 times -2 is also -6. That's nice. So this says -6z is -6, which means I can divide this by -6. I'm not going to waste a space here because I'm going to run out of room otherwise. And I'm just going to change this to -6 to -6 to 1 and 1. In other words, z is 1. Now, we're going to make, instead of going around counterclockwise, I'm going to get rid of the 3. To do that, get rid of that now. I'm going to multiply that by -3 and add it to the one on the top. The bottom one I definitely want to change because it says z is 1. The next one, I'll go -3 times -3 is, so -3 times 1 is -3 and add it to there, and I get 0, which is what I wanted to. -3 times 0, that's 0, plus 3, 3, that's still 0. -3 times 1 is -3, plus 0 is -3. That at this point says y, 3y is -3, or y is -1. And let's go put this rest back here. There we go. And again, in your notes, I probably would just, I would leave this and do the next line, but I'm just going to divide by 3 right here to save myself a little room. That becomes 1, that becomes -1. So now we have z is 1 and y is -1. Now I'm going to use this right here. I'm going to go up and start a new line of matrices. And I'm going to multiply the bottom one by, actually I don't even do that. I can just add that one to that one. So I'm going to make this 0 now. That is, what is that, row 1, column 3, I'm going to make 0. So I add that one to that one. I'm definitely not changing the bottom 2 lines, so I'll just rewrite this again. And adding this one to this one. Sorry about that. Phone ringing. I will get that in a sec. Oops, this is what you're going to have to do with homeschooling. Unfortunately, getting calls left and right. Okay, so let's go back to the first column. I'm now, or so the first row, I was just adding the top one, the bottom one to the top one. So 1 plus 2 is 3, 1 plus -1 is 0, 0 plus -2 is -2, and 0 plus 1 is 1. There we go. And then finally, I'm going to get rid of the -2 up here. To do that, I multiply the second row by 2, and I'm going to add it to the first one. So 0, 0, 1, 1. Still want this to be augmented. That's, by the way, just separating the thing. That's not really actually doing anything other than keeping the numbers on the right straight from the matrix on the left. Okay, so 2 times 0 plus 1 is 1. That doesn't change. 2 times 1 is 2 plus negative 2 is 0. And 2 times 0 is 0 plus 0 is 0. And then finally 2 times negative 1 is negative 2 plus 3 is 1. So that means my answer is 1, negative 1, 1. And now I go back to my original matrix, which now I'm going to write the equation because it turns out I do have room. X minus 2y minus z equals 2. 2x minus y plus z equals 4, and negative x plus y minus 2z equals negative 4. And I can put 1, negative 1, 1 in to check if they work. I get 1 plus 2 is 3 minus 1 is 2. Check. 2 plus 1 is 3 plus 1 is 4. Check. And negative 1 minus 1 is negative 2 minus another 2 is negative 4. Check. So that worked. Great. Okay, we're going to try one more. That's some messy ones in the equation. The problem is I don't know if they're actually... I've got some homework ones here. So let's see how they do. I'm going to do one more for you. Erase all this. Actually, what I think I'm going to do instead is actually give you a couple of problems to do rather than go through another one. So I'm going to start with just creating... I want you to take a matrix, augmented matrix, 1, 2, let's say 5, and 3, negative 2, 4, and write the equations for those. Okay, you can pause it there, just do it on your paper or something like that. Okay, hopefully you paused enough. I'm going to give you the answer now. It is x plus 2y equals 5, and 3x minus 2y equals 4. Anyway, you should be able to convert back and forth between these two. Just again, matrix terms. This is a 2 by 3 matrix. A2, 2, row 2, column 2 would be negative 2. A2, 3 would be 4. A1, 1 would be 1. Okay, there we go. Now I'm going to give you an equation to solve. Don't think this is a homework problem, but it's from the same book, so I got the homework. And we'll do just a 2 by 2. And again, I want you to... Oops, I'll write the equations up here. I want you to pause the video, and solve this set of equations. 2x plus 6y is 16. 2x plus 3y is 7. Pause the video, do the problem. Okay, now I'm going to do it for you as well. First, just convert this to an augmented matrix. That. I'm going to make this 0 first. So I'm just going to multiply the top one by, doesn't matter which one I multiply by, I'll multiply the top one by negative 1. So this gives me 2, 6, 16. Negative 2 plus 2 is 0. Negative 6 plus 3 is negative 3. Negative 16 plus 7 is negative 9. Then divide this by negative 3. You get 0, 1, 3. Top one is still 2, 6, 16. Now I'm going to get rid of this 6. I'm going to multiply the bottom one by negative 6 and add it to the top. That gives me 0, 1, 3 still. Sorry, I should be putting these little augmented matrix lines in. And the top one is negative 6 plus 6 is 0. 0 plus 2 is 2. And negative 18 plus 16 is negative 2. Then finally divide by 2. And you get 1, 0, negative 1, 0, 1, 3. So my answer is negative 1, 3. Let's plug that on the top and see if it works. Negative 2 plus 18 is 16. That's correct. And negative 2 plus 9 is 7. That's correct. Okay, try a little harder one now. Hopefully you got that one. We are going to do, and by the way, this is a little on the fly. I haven't done this one before, but let's just see if it works. I'm going to do this one. X minus 3z equals negative 2. 3x plus y minus 2z. Oops, that's a mess. This is on your notes. It's page 17 in the PowerPoint. Equals 5. And 2x plus 2y equals 4. There we go. So I'm going to start by giving you the matrix, so we all have the same matrix. By the way, you can order these differently if you want as well. So but in this case, you want the one with the 1 in the front and the top. It just makes it a little easier. So I'm going to make that 1. There's no y, so make sure you put a 0 in there. -3, -2, 3, 1, -2, 5, and 2x plus 2y. Oops, I missed something there. That was 4. Plus z equals 4, 1, 4. A little bit of a mess on this one. Okay, so 1, 0, -3, -2, 3, 1, -2, 5, and 2, 2, 1, 4. Okay, pause the video, work on that problem. Okay, I hope you're back. I'm going to go walk through it now. Let's start by getting rid of the 3 and the 2. So I'm going to multiply the top one by -2 to get rid of the bottom, and then by -3 to get through the middle, to get this one out of there. Okay, so I'm going to start with the -2. -2 plus 2 is 0. 0 plus 2 is 2. 6 plus 1 is 7. And 4 plus 4 is 8. That's it. Now I'll do the same thing on the other one. -3 is, plus 3 is 0. 0 plus plus 1. Yeah, it's just still 1. Then -3 times -3 is 9. Plus -2 is 7. Oops, that looks like something's wrong. And finally, -3 times -2 is 6. Plus 5 is 11. Let's put 1, 0, -3, -2. It makes me think the 7's wrong. Let me just check that again. -2 plus 2 is 0. That's 0. 6 plus 1 is 7. They're both 7. Oh well. Okay, so I think we're there. If you're finding an error, I might find it later. So now I'm going to multiply this top one by -2 and get rid of that 2. 1, 0, -3. Oops. -2. I'm going to leave the 0, 1, 7. I like the 1 there for one thing. Then I go -2 times 1 is -2 plus 2 is 0, 0. -14 plus 7 is -7. -22 plus 8 is -14. That looks good. This is -7z is -14, which is z is 2. Like that. Okay, now we're going to get rid of the 7. So multiply by -7. 0, 0, 1, 2 stays the same. -7 plus 7 is 0. That's 1. That's 0. -14 plus 11 is -3. And that's all we're going to do for the moment. 1, 0, -3, -2. Okay, and then finally we get rid of that -3. Fortunately, that one's already 0. That makes it a little easier. So I'm going to multiply this one, bottom one, by 3 and add it to the top. So I get 0, 0, 1, 2, 0, 1, 0, -3, and now do the top one. 1, 0, 3 plus -3 is 0, and 6 plus -2 is 4. 4, -3, and 2. Hopefully that is correct. I haven't done these beforehand, so I don't really know, so let me check. 4 minus 2 times 3 times 2, 4 minus 6 is -2. Looks good. Oops. Next one, 12 minus 3 is 9, minus 4 is 5. Good. And finally, 8 minus 6 is 2, plus 2 is 4. Beautiful. There we go. There's the right answer. Okay, that's some examples. You can go on to the homework now. If you have any questions, just give me a call or send me an email. Thanks a lot.